So here, as you can see, we have our linked list with the head pointing to node 1, and it has 5 elements with the linked list ending at node 5, and the given value of k is 2. So what we have to do is we have to reverse the nodes in groups of 2 nodes. So here the first group would be these 2 nodes, the next group would be these 2 nodes, and the last node 5, this only has one node left, which is less than k. So this is not a part of any k group, which is 2 group. So we won't reverse the last part if the number of nodes in that is less than k. And the output linked list would be this. So here, as you see, the sublist 1 2 is reversed as 2 1, and 3 4 is reversed as 4 3, and last one is as it is. So here let's have a look at a special case where, let's say, if k is equal to 1, what is going to happen then? So if k is equal to 1, then we can simply return the linked list, as there won't be anything to reverse, as k equal to 1 means that it's a one group list that we have to reverse. So here the first group is this node 1, second group is 2, third is 3, fourth is 4, fifth group is 5, and these are already basically reversed. So we simply return the head of the linked list. And what if k is equal to the length of the linked list? Let's say k is equal to 5. So here the group would be this whole group, which is of length 5, and there will be only one group. And here we will have to reverse the whole linked list. So if k is equal to length of the linked list, then this question becomes reversing a full linked list. And what if k is less than the length of the linked list? So in that case, what we have to do is we need to figure out how many groups will be there. So here in this case, the length of the linked list is 5, and let's say k is, which is less than length, k is equal to 2. So how to find the number of groups that will be formed? So number of groups would be simply length divided by k, which will give me 2. So here, as you see, the two groups would be this would be the first group, and this would be the second group, and length mod k would be equal to remaining nodes. So here the remaining node is 1, which will always be less than k, as we are doing a modulus on k. So now let's have a look at some approaches that we can use to solve this problem. So the first approach would make use of finding the length of the linked list. So here we can do this problem without finding the length of the linked list as well, but let's just focus on the first approach, which involves finding the length of the linked list. So here we have 1, 2, 3, 4, and 5. So here, first, like whenever you're solving linked list problems, so it always draw the diagram before coding. Just do a code walkthrough by drawing. This will make your life way easier for linked list problems, and then you will understand that it's really easy to solve linked list problems if you first understand the logic by drawing it. So here, as you can see, k is equal to 2 for this example. So what we need to do is, first we need to reverse this group. So what we need in order to reverse this group and update the pointers correctly. So I'm going to need a start for this sublist. So let's call it current, and I need to reverse this sublist till I reach the node 2. So previously we covered the problem of reversing linked list 2. So you can have a look at that video to understand the main logic that I'm going to use here. And so in order to update the pointers correctly, after I reverse the sublist, what I'm going to need is a previous pointer and a next pointer. So let's call it temp instead of next, because I'm going to use a next variable for reversing the sublist. So it's up to you how you name the variables. We call it next. So here, as you can see, the previous pointer is null as there is no node before the node 1. So as you know that to avoid null pointer exceptions on previous pointer, we can make use of a dummy node. So we have our dummy node here that we created, and we have k is equal to 2. Let me write that k is equal to 2. And so what we need to do is, first we need to reverse our first sublist. So how we can reverse our first sublist? So let me separate out the first sublist. So here what I need is, for every sublist, I need the start of that sublist in order to start reversing that sublist. So for the first sublist, the current variable would be equal to head, as that would be our starting point, and we're going to use another variable called as next, which will be equal to current.next. And as we iterate over this sublist, how will we know that we have reached the end of the sublist? We are going to know by tracking the count of the number of nodes, and if the count becomes equal to k, so then we know that we have reached the end of the sublist. So initially, for every sublist, we can use a counter variable which can start from count equal to 1. So currently we are at node 1, which means that we have traversed one node so far, and we set our next variable and we have current. So what we're going to do is we're going to set the next pointer of next variable as current, as we are reversing the sublist. And before doing that, we have to store the next reference of next variable somewhere. So let's call it temp, and what we do next is we need to update this reference to 2.next to point to 1, and we have already stored it in temp. And once we do that, we are going to update the current to next for the next iteration, and next will become our temp. So what's going to happen here is, since this current variable is changing and we need the start of every sublist, so let's store the start of a sublist in a variable called as left node. So why we need to store the start of every sublist is because after we reverse a sublist, we're going to have to update the pointers. So here we have the previous node, and we need to update this previous dot next accordingly once we reverse this sublist from 1 to 2. So let's have a look at the next iteration. So at the next iteration, count would be incremented, and now it's going to become 2. So for that case, let me draw this again. And so whenever count becomes equal to k, that means we have finished our iteration. So in our while loop, what we're going to have is we are going to have while count is less than k. And once we are done with this while loop, that means we have finished reversing a particular sublist. So next we have, let me delete this and rewrite it again. So I have 1 and this is 2 and this is my next. 3 becomes next, 2 becomes current, and this is my left node variable. This is my previous. So here, as you can see, that we have reversed our sublist. Now we need to update the pointers correctly before moving on to next iteration. So to update the pointers correctly, so this current would be pointing to the end of the original sublist, but now it would become the start of my reversed sublist. So what is going to happen is previous dot next, it is going to point to current, and my left node dot next is going to point to 3. So here what's gonna happen is, here as you can see, I have updated the pointers correctly, and so currently the previous is this, my current is this, my left node is this, my next pointer is this. So I have updated the references. So next, before moving on to the next iteration, I'm also going to update the variables. So what is going to happen next is the previous will become equal to left node, and my current will become equal to next. So we have 2, we have 1, 3, 4, and 5. So my node 1 will be the previous, my 3 will become current. And now I can start reversing my second group. And how many groups do I need to reverse? I need to reverse length divided by k, number of groups, and I'm going to have an outer while loop which is going to keep track of the number of subgroups that I need to reverse. So I'm going to have another counter, let's call it number of groups is less than equal to length divided by k, and the while loop that we saw in the example when we were reversing our sublist, it would come inside of this. And initially I can set number of groups as equal to 1, and once I am done reversing the first subgroup, I'm going to increment it somewhere here, and I can continue on reversing my second subgroup. And I'm going to follow the same logic that I discussed when reversing the first subgroup. We're going to have a situation like this. My dummy node will be the node with value -1, and this one is reversed, this subgroup is reversed, and the pointers are updated. And since we have number of nodes less than k, we don't modify the remaining number of nodes. And here, as you can see, that my new head of the linked list, it's going to be dummy.next. So I can simply return dummy.next and we will be done. So now let's have a look at the code walkthrough of our first approach. So here we are given the reverse k group function and we have to implement it. So what we can do here is can have some if checks on head and k equal to 1. What we can do here is just return head, and as we discussed, we need a dummy node. We can create a dummy node, new list node -1, and I can set dummy.next as head. At the end I can return dummy.next, and now I can start finding the length of the linked list. To find the length of the linked list, we can simply iterate over the linked list and keep going till we reach the null element. So I can do while current is not equal to null, and I can increment my linked list length and increment the current pointer. And after I find the length of the linked list, what we can do here is we can add another if check. If k is greater than length, then what we can do is we can again return our head, as there won't be any group which is greater than the length, so we cannot reverse anything. So that's why we returned head. So to dive into the main logic, what we are going to need is we're going to need another variable called number of groups to track the number of groups traversed so far. So I can set it as 1, and I can have a while loop which keeps the count, and I have to keep going till we have covered all the groups, and the number of groups is equal to length by k, and I can increment number of groups ++. And as we discussed, to reverse every group, we're going to need another variable called count, and I can have a while loop here which keeps on going till k. So this is like the basic structure of the 2 while loops that we are going to use, and to implement these we are going to need to set some pointers. So from our discussion, we are going to need a previous pointer which is going to be set to dummy, and my current would be equal to head initially. And inside the first while loop, before I jump into reversing a particular group, I need to set the next pointer. I can set it as current.next, and once I'm inside the inner while loop, I'm going to need another variable called stemp to store the reference to next.next, as I'm going to update next.next in the next line, which will be equal to current. And here temp will not be equal to so here next.next will not give me null pointer exception, because if there are further nodes to be processed, then there will be something, next.next would be equal to something, and so basically next will not be null. So that's why we don't need to check if next is null or not. So next I need to do is I have to update my current as next and my next as temp. So this line basically reverses my particular group, and once I do count ++, I move on to the next node. And once I'm done in this while loop, what I have to do is I have to update my pointers. So my previous .next pointer will be updated to current, and also I need another variable to store the start of my group. So create left node as equal to current, and I can update it here. Left node not next will be equal to next. So from this example, my previous would be before node 1, which will be -1, and this is going to be updated to 2, which will be current, and my left node, which will be node 1, this will point to node 3, which will be next once the first group iteration finishes. And before moving on to the next group, I need to update my current and my previous pointers. So my previous pointer will become equal to left node, and my current will become equal to next. and then we can move on to solving the second group. And at the end, as we discussed, we return dummy.next. So let's try to run this and see what happens. So yeah, so this code works, which is good. So now let's have a look at the second approach without finding the length of the linked list. So we have this linked list 1 ending at 5, and we have this dummy node with value -1, and we have our head pointing to node 1. So here, if we don't want to find the length of the linked list, then how are we going to reverse every group? So to reverse every group without finding the length of the linked list, what we need is we're going to need to know the end of every group. So here the group starts at node 1. So let me call this group start, and as we know that the end of the group is this node 2. So we are going to need to find this node 2 using the value k. So k in this case is equal to 2. So how to find the end node starting at the node? What we can do is, if we start from node 1 to reach till the end of the group, what we need to do is only need one iteration. That is, we need k minus 1 iterations. And if we start from a previous node, we can use k iterations and reach our kth node. So here let me call this kth node, and once we find this kth node, what we can do is we can save our reference to next group start, which is the start of the next group. So we're going to need this variable to update our pointers correctly after we reverse a particular group. So we have this, and let me draw this again. So I have -1, I have 1, I have 2, I have 3, I have 4 and 5. So here, so this node -1 is also going to be the end of previous group. So we can set this as previous group end, and it is also our dummy node. So to reverse a particular group, so for this group starting at 1 and ending at 2, what we can do is we can use a current variable which iterates over the group, and we have our next group end here. So in order to write clean code, what we can do here is we can use a previous element. We have our previous variable which is going to be used for this iteration to reverse a particular group. So what we can set it as, next group start, and this next group start will be equal to kth node dot next. And once we have this, what we can do is, as we are iterating over our group, we're going to use a while loop, and we're going to keep iterating until we reach the next group start, and we iterate over till next group start and not till our kth node, as when current is equal to kth node, then previous would be this node, and we are going to update our current dot next as previous. So that is why we have to keep going till start of next group. And once we do that, we have to save. So as we are updating our current dot next, we have to save current dot next first. So let me create another variable called as next, and I can save it in current dot next. And after I have saved this, I can go on till this, and after this what I can do is I can update my previous as current, and I can update my current as next to start processing the next node. And once my while loop is done, I am going to need to update my pointers. So the situation that we're going to have is -1, 2, 1, 3, and 4. So currently what we have is we have reversed this, but we have not updated the next pointer of our previous group end. So we don't have this pointer yet. So in order to update this, what we are going to do is we're going to do previous group end dot next equal to kth node, and this will update this pointer. And you might be wondering, why did we not update this pointer explicitly? Well, we actually did update this when we were reversing our group. So as you can see, we started from previous as next group start. That's why we set the previous here, and this also updated our pointers. And the only pointer that we had to update was this to point to node 2. So we can do this here, and after we do this, what we can do is we can update the previous group end to the start of our previous group. So the start of our previous group, it was here, group start. Let me call this group start. So we also need this variable so that we don't lose reference to start of a particular group. So the end of my previous group would be node 1, as when it is reversed, this will become the end, and that's why we set previous group end equal to group start. This will make sense as we start writing the code for this algorithm. And my next group would be 3, 4, and for this the group start would be node 3. And since we set the previous group end, we can set group start as previous group end dot next. So that's why initially we had previous group end here, and we had set the previous group end dot next value to our current and also to group start. And at the end, when we are done, we can simply return dummy dot next, and we will be done. And also, in what case do we have to return? So for example, if our k is large, then our get kth node. So when I say k is large, I mean k is greater than the length, but we don't know the length. So using the get kth node, we're going to reach a null node, and if our kth node is null, then that means that we cannot reverse that group, and we can simply break out of our while loop. So outside we can have an infinite loop, and inside we can have an inner while loop where we check current is not equal to next group start, and here we can find the kth node, and if kth node is null here, we can simply break out here before reaching this while loop. And yeah, this was the walkthrough of our second approach. I'm going to explain it by improving our first solution. So this was the first solution that we did by finding the length of the linked list. And in our second solution, as you know, we don't need to find the length of the linked list. And what we can do here is I can remove the logic where we find the length of the linked list, and I can simply remove it. And I also don't need this. And so first what I'm going to do is I have to write the function which gets me the kth node. So we write private list node get kth node list node int k. And I can have while node is not equal to null and k is greater than 1. Can do node is equal to node.next and k minus minus, and at the end I can return my node, which would be my kth node. And next what I have to do here is I don't need to process every group here like based on the length of the linked list. So what I'm going to do here is I am going to need to find the kth node first. So I do get kth node and then pass in current and k. And if kth node is null, what I'm going to do is going to break out. And here we don't need this condition. What I can do here is I can use an infinite loop. So here if we don't find any kth node for a group, then that means that there is no kth node and we don't need to touch that group, and we can simply break out. And here, so let's try to run this so far, and as we run it we will make it more clean. So let's run it and it works, which is good. And let's try to make it more clean. So here we don't need this count variable as we already know the kth node here. So what we can do here is we can update the logic, and we can update the logic here as removing the count variable. And here I can do is I can check my current is not equal to kth node instead of counting till k, and I don't need this counter, and the remaining logic is going to remain the same. And here instead of current I can do kth node instead, and def.next is next and current is next. Previous will become my left node, and we don't need this variable anymore. We can remove this as well. And let's try to run it again, and this also works. And can we make this code even more clean? So let's think about it. So the algorithmic approach that we discussed before writing the code, so if we try to implement that, we can make this code a lot cleaner. So let's try to use that logic here. So here what we can do is, as discussed before, what we need here is we're going to need to update our variable names a little bit. So what we can do here is I can update this variable as previous group end instead of previous. I can set it as dummy, and my current would be equal to head, and I can again have my checks as well if head and k equal to 1, can simply return head. And next what I can do is I can create the remaining variables. So for remaining variables, first I need to store the start of every group. So I create group start. So my group start would be equal to group end dot next, and to iterate over a group I'm going to need a current variable, So here I have my current as head, and it won't be head every time. So when this while loop runs second time, it's going to be updated. So it's going to be updated as group start, and I can remove my left node next. And what I can do here is I can write another variable which is next group start, should be equal to kth node dot next, and I can define a previous variable which is equal to next group start, and here my current check would be on next group start instead of kth node, and here I can have my next as current dot next, and instead of next dot next I'm going to update my current dot next as previous. And what I can do here is I'll update my previous as current and my current as next. So since we would have already updated the reference from node 1 to node 3 initially, we just need to update the previous group end dot next reference. So our previous group dot next reference would be equal to our kth node, and we can update our previous group end as group start, and we don't need to update these anymore. So that's what we need, and let's try to run this. It says cannot find symbol. Previous group would be previous group end, not next. So let's try to run it, and yeah, it works. So yeah, thank you for watching, and I'll see you in the next video.